Continue talking about solving linear equations. This is part 2 of what we started last time. So last time we solved a bunch of equations, but none of them had fractions. Today we're going to solve equations with fractions. Could be one fraction, 2, 3, or more. Can you guys hear me and see my screen? Everybody, do you hear me? Do you see my screen here?
Yes.
Yeah. Yes, Professor.
All right, so let's look at some examples of equations with fractions. The first example here would be if you have an equation that looks like this, x over 4 equals 3, for example. So you want to get the x by itself. So we want to solve this, meaning we want to find the value of x. So to get the x by itself here, we have x over 4 equals 3. Basically, the operation here is a division. It's a division between x and 4. So to cancel the 4, to isolate the x, we need to get rid of the 4. So the opposite of the division is a multiplication. So we'd have to multiply both sides by 4. That way, 4 by 4 cancels out. You end up with x by itself. And you multiply these two, and we get 12. Okay, so one step. So what we call the multiplication property of equations. That's when you multiply both sides. Last time we had, let's say we had something like this. This is a multiplication, so to cancel the 3, we divide it by 3 on both sides. But today we have a division, so we do the opposite. We do the opposite of division, which is multiplication. And the solution here is 12. So that's a one-step equation with one fraction. We can do it this way, or we can do it another way. Second method is to take the equation x over 4 and 3. Basically, we turn the other one into a fraction as well. And once we do that, we can cross multiply. So you can take x times it by 1, take 4 and times it by 3. So you get x here and 12. You get the same answer as before. So this is cross multiply. Or cross multiplication. Okay, here we use the multiplication property with times by 4 on both sides, but here we cross multiplied. So we go like this, then the other way, x times 1, 4 times 3. Either method is fine. As you can see, the result is the same. So that's the method of cross multiplication. Let's do another one. So we could have, let's say, negative 3x over 2, and maybe 7 over 5, for example. It's another equation here, so we need to get the x by itself, isolate it. We need to find the value of it. Okay, so what would the cross multiplication here be for this one? If you cross multiply this, what do you get? What's the first multiplication?
3x times 5.
Okay, negative
3x times 5.
That's right, so negative 3x times 5. And the other multiplication?
7 times 2, or 2 times 7.
Okay, either way. So we'll multiply this way, so 2 times 7. That's what we call it cross multiplication. Because we cross multiply, basically. And now, once you cross multiply, the fractions are gone, which is good. Now we can multiply and isolate the x, so this is negative 15x and 14. And one last step here to get the x flats off. What is it? I'll do one more step.
About 15, negative 15.
I'll repeat that. What do we do with negative 15?
Negative 15, we're going to multiply into x to equal 14.
So we want to cancel negative 15, right? We have a multiplication here. What do we do to cancel this negative 15? What is the operation? Kind of
Division.
similar to this. Okay, so we want to cancel this negative 15. What is the exact operation to get rid of it? We need to, the opposite of multiplication is?
Divide.
That's right, division. So we need to divide by negative 15. Also divide the other side by negative 15. That way these two can cancel out. When you divide something by itself, it cancels out. You get x by itself. And this basically the answer. Try to reduce this if possible, but nothing goes into 15 and 14, so that's the answer, negative 14 over 15. So that's the case with one fraction or two. You just cross multiply, then isolate the x. Okay, now we're going to see what happens if we have multiple fractions, not just two, but three fractions or more in one equation. That's another equation. Let's say you have x over 3 plus maybe 2x over, let's say, with 5x over 4, and some other number on the other side, maybe 1/6. So we have a bunch of fractions here in one equation. Apparently, we can't cross multiply as we did here, because we have more than two fractions. Cross multiplication works if you have two fractions, one on each side. So let's see how to do this one here. So any ideas on how to approach this problem here? Everybody? So we're going to try to get rid of all these fractions together at the same time. So what do you think we need, or what do you think we do first in order to get rid of all those fractions? Okay, it's pretty simple. When you have a bunch of fractions, we just need to find the LCD. We need to find for all these denominators, 3, 4, and 6. Once we find that denominator, we can use it to get rid of all these fractions. What's the LCD for 3, 4, and 6? What is the common denominator? In other words, a number that all these three can go into. What's that number?
3.
What is it?
3.
3. Not all of them go into 3. A number that all of these can go into. It's a bigger number that can go into all these three can go into. We talked about the LCD and fractions in the first and second day of class, so that's very important. We need to now do that. So the common denominator for 3, 4, and 6 is the first common multiple, basically 3 and 3, 6 and 3, 9, and so on. So if you do multiples of all, the LCD is 12. So 3 goes into 12, 4 goes into 12, and also 6 goes into 12. That's the first thing you want to do. You want to find the LCD. Once you find that LCD, we just take it and we're going to multiply all these fractions by the LCD. Okay, so we're just going to take this 12 here. I'm just going to multiply it by each one of these fractions. Okay, and now that we did that, so before actually doing the multiplication, we will reduce or simplify these fractions. As we saw before with fractions, before multiplying them, we try to simplify them as much as possible. Again, I refer you back to the first and second lectures of this semester. We talked extensively about fractions. By now, you should know how to find your LCD and how to simplify fractions. So before multiplying, so we're going to reduce or simplify. So 12 by 3, that would be, if you simplify 12 by 3 or 3 into 12, how many times is that?
4.
That's right, we get 4 here. And the fraction is gone. Times whatever this is, bring it down for now. And you repeat the same thing for the other ones. So again here, before multiplying, let's simplify to get rid of the fraction. So 12,
3.
that's right, 3 times.
5x.
That's right, just going to bring the 5x down here. And repeat the same thing here.
2 times 1.
That's right, 12 by 6, that's 2 times 1. That's it. Once you get rid of the fractions, things look much simpler and make more sense. So this is what we solved last time. We did a bunch of these without fractions. So first you want to get rid of the fractions. Again, 2 main steps. Get your LCD, multiply all by the LCD. You can easily cancel that because this one is a common denominator, which means all of these can go into it evenly. So 3 into this, this into this. That's what makes all these denominators disappear. The rest is pretty simple. 4 times x, that's 4x, plus 3 times 5x, 15x, and 2 here, 2 times 1. And from here, we know what to do. Okay, so what is the next step? Especially here, what do you do? On this slide.
Combine common denominators.
That's right, combine like terms. These two terms, you're going to combine them. So that's 19x. Here, nothing, just 2. Finally, we're going to divide again by 19 to cancel it. And 19, so x is 2 over 19. This is fine, that's the answer. Try to simplify it if possible. Nothing goes into 2 and 10 and 19. That's basically the answer. Okay, so the 2 main steps are these. Just basically find LCD and use it to cancel the denominators. Once we cancel it, we repeat all the steps we've done last time. We've done many examples like these. Simplify each side first, then move the x's to one side, the numbers to the other, and so on. And isolate the x. Okay, any questions about this problem here, everybody? We're gonna do another one like that. Okay, let's do another example like this. So let's say maybe 2x over 3 minus 1/6. Maybe x over 9 here. As you can see again, we have 3 fractions. We can't cross multiply because we have a bunch of them. There could be even more fractions. Doesn't matter if you had more. You may even add, let's add one more number here, just see. So we could, for example, add 2/3 here. So we have 4 fractions, but again, the method, the steps are the same here. You just want to try to get rid of all these fractions all at once. Once they're gone, the process becomes easier. I'm going to repeat the same steps here. All right, so what do we do first here? Just look at the previous example, it's quite similar.
LCD.
That's right, find the LCD, which is the LCD for all these, 3, 6, 9, and 3. What would that number be that all of these can go into evenly?
18.
That's right, 18 is the perfect denominator, the least one, the least common denominator. Proof is all these go into it. Good, so we have that. Let me rewrite the equation here. You want to leave your first equation here intact. You don't want to touch it just in case you want to go back to it. So I rewrote it. All right, first step, good. We found the LCD. What do we do with the LCD now? What do we do with this number here, the LCD? Just like the previous example, what happens to this equation with LCD? So right here, the step is here, find the LCD, and multiply. Okay, so multiply all by the LCD, meaning just put that 18 next to each one of these. Just like that. Okay, and all these denominators will magically disappear all at once. Okay, what happens to the first one here? What do you get?
$32x. 32x over 18.
32x, you said?
Yeah.
Why do you say so?
Times 2.
Just give us the first step. So we're actually not multiplying yet, but just like we did here. So before multiplying, this is what happened. We're going to try to do the same thing here in order to cancel the fraction. So what is the first thing you do here in this fraction? Again, just like this, see how we went from here to this. We're going to try to do the same thing here. So what exactly happens here now? It's very simple, and just like we did here. What do we do again? So here we reduced 12 by 3. We divided and put the result here. Same thing here. Before multiplying, we had to cancel these or simplify these to cancel the fraction. 12 by 4, 3. Let's do that over here. So what do you get? It's going to cancel these two, reduce them. 18 by 3 will be 6 times 2x. And you do the same thing for the rest of them. As you can see, the fraction is gone because we divided this by the LCD. Before multiplying, it's probably easier. If you multiply and then divide, it might get a bit complex, but divide first. And what do you get here for the second one? If you divide, again, we need to divide this way, simplify. 18 by 3 by 6, that's 3. Bring the 1 down. And here, same thing again, 18 by 9, that's 2, times the x. Plus, finally, again, we don't want to multiply yet. We want to get rid of the fraction, so it would be 2 times 18 by 3, that's 6. So now, as you can see, all the fractions are gone, and it's much easier now to combine, simplify, and isolate the x here. So that's the key here. You got to find the LCD, multiply all by the LCD. two main steps. It doesn't matter how many fractions you have. You could have these or a bunch more. Same way, you can get rid of all these denominators at the same time. So make sure you get the right number here. Make sure all of these go into it evenly. That way, when you divide, all the fractions are gone. Okay, there's nothing left when you divide. These denominators, all of them go evenly into 18. Okay, let's do the multiplication now. That's 12x minus 3, 2x plus 12. Okay, so this stage, we have numbers and x on this side, also x and numbers on this side. If you recall from the previous lecture, what exactly do we do now at this stage? So what exactly happens now? So we're going to have the x's on one side. So we're going to move this one over, and we're going to move the negative 3 to this side at the same time. Could still do minus 2x on both sides, then do plus 3, But I think this is easier and faster. You can do both at the same time. So 12x stays here. You have 2x on this side. We're going to move it to the other side with the equal sign. What happens to the 2x if it moves over to this side? What happens to the 2x? Anybody? We talked about this in detail last time, and we did a bunch of problems.
The negative with the minus to control.
Exactly, that turns into the opposite sign because we moved across the equal sign. So this turns into negative 2x. Same way, we're going to move negative 3 over.
12. 3 plus 12.
That's right. Turns into positive 3. And bring the 12 down. That's it. So you can do both of these at the same time. And your signs are okay. As opposed to if you're not sure what to subtract from where and you get confused, this is easier. Have the x's on one side, the numbers on the other. Now we have like side or like terms on each side. We can go ahead and combine like terms. So 12x take away 2x.
10x.
That's right, 10x. And on this side, of course, I have 50. One final step. What is it?
Divided by 10.
Exactly, divided by 10 here. 10 on this side. So the 10's cancel out, we get x. And can we reduce this fraction?
No.
10 over 15 over 10. What goes into both? We can reduce these by 5. Let's write it first and then reduce it. So 10 over 15. We can reduce this by 5. 5 into 5. 3. 5 into 10. 2. Finally, we can write our answer as x. But actually, let's write it down separately. Just going to have to rewrite it here. So x is 3 over 2, which is fine, and the answer can be a fraction. You just try to reduce it if possible, which we did, and that's your final answer. You may write it as a mixed number if you want to, but so it's not too bad to solve equations like these. It took us how many lines? 1, 2, 3, 4, 5, and 6. Not too bad for a fraction or for an equation with a bunch of fractions. Okay, again, always go by these two main steps. You want to get rid of all the fractions, so you need the LCD. And it doesn't matter how many you have here, it works the same way. But if you have only one fraction, it's probably easier to just cross multiply. Make the other one a fraction as well. If you have two fractions, same thing, just cross multiply. No need to find LCD. But if you have more than two, you have 3, for example, you need that LCD. So you can cancel the fractions. Or if you even if you have 4 like this, you have to cancel out of it. You need the LCD for that. Okay, so that's 4 fractions, and we canceled all of them at once. So let's have another one, a little different, kind of like this, but with slightly different numerators, not the denominators, but the numerators. 5, okay. Let's say you have 2x minus 1 over maybe 15 here, or 5. On the other side, another one with something like this. Say x plus 2. Okay, so another one here, no big deal, just an equation with 2 fractions. So actually there are 2 ways we can do this one. Either one should lead to the same result. 2 ways from what we've seen so far. So how do you want to solve this? Which way do you think is better or easier? Based on the methods we used so far.
Find the LCD.
That's one way, that's right. Find the LCD and do exactly like this. It will be even shorter because we only have 2 fractions. Or let's say you don't want to find the LCD. What's the other method we can use here?
Cross multiply.
Exactly, that's right. So either LCD or we can say or cross multiply. Either way, we get the same result. So let's do just, let's try to cross multiply. Or actually, let's use both. Let's try to do both. So what is the LCD here for 3 and 5?
15.
That's right, that's 15. Okay, so let's multiply both by 15. So here, when you multiply these two, you're gonna need parentheses, because 15 will be multiplied by both of these. We're gonna need parentheses also here. You're gonna need parentheses, not just a dot. If you put a dot for multiplication here, it means only x times 15. But we actually wanna multiply by both. That's why we use the parentheses. And we're gonna repeat the same thing as before. All right, so what happens now? Do we distribute first or do we do something else?
We have to simplify it.
Exactly. What exactly do you simplify?
So you're going to get 3 into x.
That's right. So we're going to cross these out, simplify these. So 5 into 15, which is 3. Then you're going to have, and bring the parentheses down. We're going to multiply later, just like we did earlier. 15 by 5 cancels out. We have 3 minus 1. Same thing on this side. So we have 15. Reduce that by 3. We get 5. Bring this down, x plus 2. And once the fractions are gone, we solve normally as we did last time and today. So what do we do now at this stage? What happens now, everybody? What is the property that we use now? Clearly, we have some parentheses here. You have to get rid of them. How do you get rid of the parentheses again?
Distributive property.
That's right. We're going to distribute this and this. So this will be 6x minus 3, 5x, and plus 10. Okay, that's good. Parentheses are gone. As you can see, now we're at this stage here. We're going to do the exact same thing. as here. So what exactly happens here now?
You're gonna have to move over all like terms to one side.
That's right, we're going to move the x to this side and -3 to the other side. Both at the same time, quick, so we don't have to do it in 2 steps. So 6x, take away, again, don't forget to change the sign. Positive 5x turns into -5x. -3 turns into +3. Bring down the +10. And we're almost there. 6x, take away 5x, that's 1x or x. And of course, that's 13. Okay, that's one way, the way of the LCD. Find LCD, multiply, simplify. Or, since we only have 2 fractions here, we could cross multiply. Doesn't work if you have 3 or 4, but if you only have 2, you can use that. So let's rewrite the original equation again here. So we have 2x. Let me write this smaller here, 2x minus 1 or 5. And x plus 2 over 3. Okay, so let's do again, the cross multiplication way. We did the LCD here, which is 15. So here, again, if you don't want to find the LCD, that's fine. Times this, by this, and simplify. So we're going to take this, 2x minus 3, 2x minus 1, multiply by 3. Could put 3 first. 3 times this. Again, this has to be in parentheses because 3 will times both of them. Then the second multiplication, 5 times these two. So again, they have to be in parentheses because 5 will be distributed over both of them. As you can see now, these look similar, okay? We got here in a slightly two different ways. So again, x will be 13. This step, we repeat the same process. The answer will be the same. So that's how you solve that if you have 2 fractions. We probably want to go with cross multiplication, maybe, but if you feel comfortable with this, that's also fine. Okay, you guys got this? Any questions about this problem here?
Nope.
Okay, so that's pretty much it for solving linear equations with fractions or multiple fractions. So last time, again, we saw to solve these without fractions. These or something even longer. We'll learn all that in detail. Again, the previous lecture, you may want to rewatch that. Today, we just added a couple more steps, basically getting rid of the fractions in 2 different ways, either by cross-multiplying or by finding LCD. And that's pretty much the lesson for the day. Okay, we're gonna have another lesson on equations next time. Maybe see some applications like word problems into equations, and then we solve those equations. Some applications basically next class. Right, so let me give you a few practice problems and all this to work on your